Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Farhan Ahmad, and today we are from the group of Selling Freedom. We are going to present to everyone about the assignment 2 that we have received before this, which is the entitled of the various material used and their application in shipbuilding. So first of all, what are we going to in our discussion is, first of all, what are the agendas that we are going to talk about, which is first of all, we are going to talk about the metal in construction of ships. And then next one, we are going to proceed with the second sub discussion, which is known as the timber in shipbuilding. The third one, we are going to proceed with the discussion of the about the usage of the glass reinforced plastics and polymers. Last but not least, we are going to discuss about what are shipbuilding materials, definition, classification, and specification. So next, I'm going to pass our presentation to one of our fellow friends, which is Muhammad Adam and Nurfatihah. Please welcome.
Okay, Assalamualaikum, Dr. Ali. Today, Fatihah and I will be presenting about metal used in construction of ship. In this part, we will be explaining the definition. In this part, we will be explaining the definition and type of metal. In this presentation, we will discuss only four types of metal, which is grey iron, stainless steel, aluminium alloy, and titanium alloy. Significance of metal, a crucial part in shipbuilding. Metals are very crucial component to consider when talking about building a marine vessel, since they are one of the most important factors in creating a sustainable large-scale vessel that is sturdy enough to travel mostly on water and withstand the force of the sea. The metal are glossy. The characteristic of metal is they are glossy, hard and strong, as well as an excellent heat and electrical conductor. There are two kind of metal. There are two type of metal, which is ferrous and non-ferrous metal. The, fe- the ferrous metal are those contain iron. The iron produce magnetic effect to the item while also causing it corrosive. Non-ferrous metal, on the other hand, contain zero or little iron, making them a perfect insulator rather than conductors, and such metal don't have any magnetism. Ferrous metal. To produce a ferrous metal, it has to be made up of iron and other metal. While iron is sometimes referred as a ferrous metal on its own, the term refers to any metal alloy that contain iron. The valence of a metal is calculated to determine if it is ferrous or not. The metal has a valence of two and above, indicating that that is ferrous. One of the example of ferrous metal is grey iron or grey cast iron. Grey cast iron is common because it is among the most cost-effective form of iron casting. For most implementation, it has adequate ductility, tensile strength, yield strength, and impact resistance. Grain iron is also great at dampening vibration, making it suitable for machinery, platform, and a variety of house application. Grey iron also has a high electrical conductivity, which means it conduct heat more efficiently. The strength of grey iron is to survive the thermal cycling. Thermal cycling refer to the process of part switching between warmer and colder temperature. Although thermal cycling can cause stress and permanent deformation in some metal material, grey iron has shown to be able to withstand the strain of thermal cycling and not be stressed as quickly. Every year, more pound of grey iron casting are manufactured worldwide than just about any other form of metal. For instance, almost every manhole cover is made of grey iron. But in shipbuilding, as a met as a metal for vessel engine, but in shipbuilding, grey iron is used as a metal for vessel engine and component. For example, piston, hydraulic part, valve, wind turbine housing, also machinery bases. Next is stainless steel. Stainless steel is also one of the examples for ferrous metal. Stainless steel refers to a group of iron-based metal that are resistant to corrosion and heat. The most distinguished feature of stainless steel would be its minimal chromium level of 10.5% that provide high corrosion resistance over all the other steel. Stainless steel is mainly made up of iron and carbon, but it also contains a number of alloying elements. The most common of which is chromium. It highly corrosion resistant due to its chromium content. Steel with a minimum chromium content of 10.5% is 200 times more corrosion resistant than steel without it. Stainless steel, it has high strength and durability, as it high and low temperature resistant, enhanced formability and easy fabrication, low maintenance, long lasting, attractive appearance, and environment friendliness. And it is not necessary to treat, coat, or paint stainless steel after it has been placed into operation. The uses for stainless steel mainly is for deck part of vessel and ship, such as deck eyes, anchor rod bracket, machinery housing, shackles, handrail, and also boat propeller shaft. That's it from me. Fatihah will continue this.
Assalamualaikum. My name is Nurfatihah binti Johari, and today I will be talking about the non-ferrous metals. So what are non-ferrous metals? In general, non-ferrous metals, they contain no iron or less iron than the other elements. Non-ferrous metals containing iron and their alloys are called non-ferrous metals. This gives them a higher resistance to rust and corrosion, which also makes them ideal for gutters, liquid pipes, and roofing. Finally, they are non-magnetic, which is crucial in many wiring and electrical applications. So have you guys ever wondered what are the properties of aluminium alloy? So the properties of aluminium alloy, they are light, they are strong, they are ductile at low temperatures. Casting alloys and rod alloys, there are two main types, each of which is further divided into two subcategories, which are the heat treatable and non-heat treatable subcategories. Rod materials such as roll plates, foils, extrusions, they use only about 85% of aluminium, and if they are left unprotected by anodizing and a proper painting technique, the aluminium surface, they will produce like a white protective layer of aluminum oxide. And aluminium alloy, they are superior corrosion resistance, especially in marine applications at high temperatures, which makes them ideal for boiler and condenser tubes. Now, I will be talking about the uses of aluminium alloy. I'll be giving you 4 examples of aluminium alloy in marine applications. The first one is the hull. So what are the functions of aluminium alloy in building hull? So they are functioning in reducing the weight and the ship structures by 50% compared to the low carbon steels. Aluminium alloys, they are used in the building of superstructure of ships, hulls of hovercraft, fast multi-hull catamarans, and surface planning of vessels. Not only that, but aluminium alloys, they are also used for helidecks and in the construction of helideck support structures on offshore oil and gas rigs, oil rig sky towers, and telescopic personnel bridges. Next, I will be talking about the titanium alloy. So what are the properties of titanium alloy? As compared to other lightweight materials, it has low weight, higher tensile strength, and heat and oxidation resistance. It is frequently found in firewalls. Titanium is a corrosion-resistant metal that should be considered for marine and offshore applications where weight, space, or corrosion or erosion are concerns. Since titanium has no corrosion allowance, equipment can be built to meet the bare minimum of mechanical strength and handling specifications. Titanium's outstanding corrosion resistance is due to the metal's stable, tenacious, and permanent oxide film, which is present even in highly contaminated seawater, offshore produced fluids, and all but a few non-produced fluids. Now that we have learned the properties of titanium alloy, we will be talking about the uses of it. Based on the corrosion resistance, durability, and ease of maintenance, titanium is used in a wide variety of marine and offshore equipment and components. Deep diving submersibles such as the diving bell hatch doors, hydraulic cylinders for steering hydrofoil planes, jet fuel inducers, precise vessels, pumps, advanced electronic packages and sonar devices, springs, impressed current system anodes, and desalinations for deep sea cameras are just some of the applications. That is all for me. Thank you. I will pass to you to the next presenter.
Hi, Assalamualaikum everyone. My name is Sazwani, binti Khari Azhar. Today I will present about timbers in shipbuilding. I will present about the definition of timber and the type of wood used. For the definition, for wood in shipbuilding has a structural element. In addition, it is also used some that are used in shipbuilding parts. Next, the timbers used in shipbuilding is intended for ship and types of timber used in the ship in the building, as well as grouping. Therefore, provide in standard size for the shipping industry is also one of the type of timber used in shipbuilding. Type of timbers are also classified into two hardwoods and softwood. Next, I will discuss about the type of wood used. There are three types of wood used, namely bamboo, birch, and cedar. For bamboo, this wood is not available with roof. This is said because mostly this wood is used as exterior construction. This bamboo wood is also said to be a Japanese bamboo fence, which can be renewed for up to 5 to 7 years. Next, bamboo also withstand compressive strength greater than brick-like strength of engineer. Also, this bamboo is very strong. After that, bamboo also used widespread as in water transport, in sometimes as flagpole. Last but not least, cedar. Cedar has a beautiful color. These timbers may be vary from palest yellowish to dark reddish brown. That's why the timbers so beautiful. Next, cedar also inherently immune to rust, rot, and insect attack, as well as moisture, and also able to last between 15 to 20 years. After that, cedar also used as deck of ship. They have different degrees of toughness and decay. That's all for me. I will pass my presentation to Hasanah. Thank you.
Pole. The net is a pitch. Pitch. Pitch is durable as a solid slab maple. Produces a long-lasting furniture. Tolerances to road decay and instead is a very limited. May be formulated with a fire retardant covering. Well suited in the fire resistant buildings. And the uses of pitch in the shipbuilding is used during shipbuilding of the keel. Applied as a part of cabin and plate panels.
Okay. Thank you, Sazwani and Hasanah. My name is Khairul Khamsani, and I will explain about the usage of glass reinforced plastic and polymer. In this part, we will discuss about two things, which are the glass reinforced plastic and the fiberglass. Glass reinforced plastic, or GRP, also known as the fiber reinforced polymer, FRP. This material were made from the polyester resin. glass fiber reinforcement, and fill it with the silica sand. And the first ship construction that using this material was applied in 1973 on the Mine Countermeasures Vessel MCMV by the HMS Wilton. And the objective of using these materials were to help the ship works in extreme condition and resistant to impact and fire. And there also the advantage of using this material, such as non-magnetic behavior, fatigue resistant, economic, and technical feasibility. And next we'll discuss about the sandwich structure design. This sandwich structure design was applied in the ship hull, and it consists of three elements, which are the pair of tin, 0.4 to 0.6 inches, and the material was strong glass reinforced plastic. And the second element was lightweight core material, 2.4 to 6.0 inches, such as hardwood and foam plastic. And the third element was an adhesive bond. And as you can see here, this is the example of the sandwich structure design. And it consists of the pair of tin that made from the strong glass reinforced plastic. And the middle one was using the lightweight core material such as hardwood or foam plastic. And there also the advantage of using this type of structure design, such as it will reduce the hull maintenance cost and good shock resistant, double hull, safe against water penetration, and non-detachable magnetic signature. And this is the comparison between the GRP and the aluminium and the stainless steel. For the magnetic signature, the aluminium and the stainless steel are greater than GRP. For the light ship structure weight, the aluminium 23% heavier than GRP, while the stainless steel 47% heavier than GRP. And for the material acquisition cost comparison, the aluminium are less than GRP, while the stainless steel are equal to GRP. And last, we will go to the aspect of the producibility comparison, which are the aluminium are less risk than GRP, while the stainless steel are higher risk than GRP. Next, I will tell about the glass reinforced plastic material. This GRP material was consist of three types of material, which are the vin, ester resin, epoxy resin, and fiberglass. First, we will go to the vin ester resin, as known as VE. This material was used to protect the ship hull structure, which it give more protection and withstand the chemical corrosion. And where did this material was applied? This material was applied in the sandwich hull structure, and it give more flexible and high hardness. And for example, this material was applied in the Swedish HSP class vertical hull structure, and in the structure, it's applied the PVC core and the carbon fiber and also the vin laminate. And next, we will go to the epoxy resin, and this material same with the vin ester resin, and it used to protect the surface metal from the corrosion, and it has its own characteristic such as outstanding thermostability, tensile strength, chemical resistance, and excellent adhesion performance. And where did this material applied? It used as a coating to the ship, such as shipbuilding, maintenance and repair of the multiple parts of ship, such as underwater hulls, ballast tanks, deck, and structure. Next, we will go to the last material, which is fiberglass. This fiberglass was used in shipbuilding construction, such as in building lifeboat or life raft cover. And there are many types of fiberglass, such as carbon HM, S-glass, E-glass, Kevlar 49, and polyethylene. And this fiberglass has its own characteristic, which are resistant to moisture and chemical aggression, high strength, from 1.5 to 2.0 GPa, lightweight, and increase the structure strength from the impact. And it also water resistant and the fire resistant. Next, we will go to the properties of the reinforced fiber. And as you can see here, there are three types of fiber, which are carbon HM, carbon A, and boron. And we will go to the first density. Carbon HM have a 1.8 density, while the carbon A have a 1.9, and boron have a 2.6 density. For the fiber diameter, the carbon HM 7 to 10, while the carbon A 7 to 10, and the boron have 130 fiber diameter. And the young modulus, carbon HM have a 400, while the carbon A have 220, and boron have 400. And last, for the tensile strength, the carbon HM have the highest tensile strength, which is 20 to 2.8, while the carbon A have 3.2 tensile strength, and the boron have 3.4 tensile strength. Next, I will address for the next discussion. Thank you.
Alright, thank you Muhammad Khairul Danish bin Khamsani for your presentation just now. So next, last but not least, we are going to discuss about our last subtopic in our discussion for today, which is the shipbuilding materials definitions, classifications, and specification. And then in our discussion, we will discuss about three different things or parts in our topic for today, which is first, we need to know what are the definitions involved in this subtopic, and then what are the properties of the materials involved in shipbuildings, and then the last but not least, what are the ship materials classifications involved in shipbuilding. Alright, so first of all, what are the definition of classification society? So first of all, according to International Association of Classification Society, also known as IACS, classification society actually will generate their own classification rules respectively according to their country. And then this classification society will also verify the rules of compliance according to everyone that involved in maritime sector, including the ship operators, ship owners, and also the shipbuilders of the shipyard. And then all the classification society are need to be independent and not being controlled by anyone, including any government of the country respectively. And then last but not least, this classification society actually authorized to as defined in SOLAS chapter 11-1, regulation 1, and IMO Global Integrated Shipping Information System, also known as GISIS. These are the example of IACS members. Actually, all of the members of this example, they will have a quality system certification scheme, also known as QSCS. These four example are, first of all, we have the ABS, also known as American Bureau of Shipping, and this one is emphasized to be applied especially in American country. And then Bureau Veritas, this is one of the European classification society. And then we have Chinese classification society, which is known as China Classification Society, which is also known as CS. Alright, next we are going to see what are the example of IACS members. Actually, all of these four examples, they have one similarity, which is they have a quality system certificate scheme, which is known as QSCS. So first of all, the first example we have here is American Bureau of Shipping, also known as ABS. This classification society actually emphasized for those ships that were from American, and they are founded there around in 80 something. And the next one we have the Bureau Veritas. Bureau Veritas actually is one of the classification society that were registered and established in European country. and most of the European country will use this type of classification society to verify all the criteria that have been fixed and need to be compliant with their application. And then next one we have the Chinese based classification society, which is established in Beijing, which is known as China Classification Society. This classification society also known as CCS. Last but not least, we have an Italian classification society, which is known as Registro Italiano Naval, also known as RINA. And this classification society was registered in 1861, and their base is at Naples. So, what are the importance of classification society? It's easy. First of all, we need the classification society to ensure all the global industry in maritime will involve within international standard. This is because we want to ensure that all the people that involved in maritime sector, first of all, we want their safety to be uh, confirmed. So at least when they have some issues regarding of their safety and health, we can take action because some of the company might looking for some shortcut, right, for cutting their cost. So based on the classification society, at least we can ensure the safety of the people involved within this industry. And then next, we will have more involvement of the domestic shipbuilders will be complied with the shipbuilding standards of community. And then the next one, we will have to ensure the process of refining and identifying and development of new shipbuilding standard. Because why? As we know, as times go by, the world is evolved. Everything become modern, and including the method of how the ship were built. So as the time goes by, things change. So as the change occur, we need to ensure the safety will be not jeopardized. So as we refining and identifying the development of the new shipbuilding standard, at least we can ensure those ship will be very quality, and then the safety when it went to seagoing, seaway, those people who on board the ship will be returned to their home safely. And then the fourth one, this will help to get a better coordination of existing standard become smoother. Because why? As we know, as in all around the world, we have many type of ship, and we have a multiple company that will produce a lot of ships. So based on all of these ships, there might be some differ between each other. So the way we want to overcome the differ is by ensuring all the standards will become smoother and being coordinated. Last but not least, we will be able to develop an optimal marketing strategy for industry participants. Why? Because actually in maritime industry, they are very competitive. So the way we want to make the company become competitive, we want to make sure it will happen in a healthy way. How? By regulating the standards and development that are coordinated safely, and last but not least, it will help to make our marine industry become better in the future. Next presentation will be proceed with our next presenter, which is Tuan Aisya. Please welcome.
Assalamualaikum and hello everyone. My name is Tuan Aisya Nabila binti Tuan Azhar, and I'm going to tell you about shipbuilding material definition, classification and specification. First, let's go to ship material specification. Okay. Material used in shipbuilding must be properly specified. Item can be specified as first is part number. This include a combination alphanumeric character. The part number is unique and will not change by time. The owner will use this numbering system to order spare part when the ship is finally built and used. Second is item description. The description must be clear, so procurement is right. The part register determine finish. color, and upholstery. Third is manufacture. The shipyard might have a preferred manufacturer. Manufacturer use as main source for their supplies, and the last one is quantity required. Quantity required determined on weight, length, and volume. Okay, next slide. We will going to talk about properties of material. Okay, actually, there are several properties of material, but I will only highlight 3 of them. First, we have ductility. Ductility refers to the nature of material deformed before failing due to stress. Closely related term is known as notch ductility. This property depend on different factors. Next is toughness. Toughness is able to deform the plastic and tolerate crack while maintaining the integrity of the overall structure. And last but not least is fusibility. Fusibility is ability of two different metals to alloy together relatively at low temperature. For example, bismuth and lead. Okay, next, ship material classification. Ships are generally designed based on rules set by the Classification Association. Okay, first, rules for the construction of GRP hulls are based on use of unsaturated polyester resin system with glass reinforcement. Great revenue by using contact printing technique. Okay, for steel and aluminium alloy craft, the rules state that material must be marine standard. General classification requirement must be based on the electric process. Okay, the rule becomes strict on the use of material and grade of say are explained as follow. For grade A, might say used in large number of sheet structure with a thickness of less than 20 milliliter, such as dam, tank cover, non-strong deck, and upper structure. For grade B, might say used for strength member thickness 20 to 25 milliliter. For grade C, durable stay that is resistant to crack propagation and has higher strength. It is used for structure as thick as 25 milliliter. Okay, that's all from me. Thank you.
Alright, thank you Aisya Nabila for your presentation just now. So ladies and gentlemen, we have reached at our end of presentation. So in case you have any question you want to ask us regarding about this chapter, which is about the ship materials and their application in shipbuilding, don't hesitate to ask us any question that might running through your minds in case you want a further clarifications. And if there is any mistake that we have done just now, also don't hesitate to come to us and give us some advice what we have done wrong. All right, so thank you ladies and gentlemen, that's all from us, the group of Selling Freedom. Till we meet next time, assalamualaikum warahmatullahi wabarakatuh. Thank you ladies and gentlemen.